3 years ago, our network switch was so bulky, we had to carry it with 2 hands. We challenged ourselves to make it smaller than a standard sheet of paper, and here's where we are today. This redesign alone saves us more than 2 kilograms of weight across the aircraft. And through integrated design, we've been able to add additional functionality to our network switch, eliminating the need for an entirely separate device. We've done the same thing with our flight computer. It receives pilot inputs and sensor data from around the aircraft and translates that into instructions for the propulsion units and control surfaces. And here, we challenged ourselves to take all that functionality and put it into a robust device that weighs less than an iPhone. And that's exactly what we achieved. With our vertically integrated approach, we've made similar improvements across our entire suite of flight electronics, reducing mass and volume while increasing redundancy and integrating multiple functions into fewer devices. All of our software speaks a common language, and all of our hardware shares common interfaces, meaning there are no layers of conversion or translation required in each connection. For more than 5 years, I've had the privilege of leading the team at Joby, responsible for designing all of the electronics needed in our electric fly-by-wire airplane, including sensors, networking, and processing. I previously worked at Tesla and Apple, where I tackled challenges like these and saw firsthand the power of vertically integrated design to deliver incredible efficiency and value to customers. We've taken the same approach here at Joby. By designing, building, and testing our flight electronics and wiring systems in-house, we were able to significantly improve not just the performance and safety of our aircraft, but also its assembly time and maintenance profile, with fewer parts to install and service. A lot of these devices perform functions similar to your smartphone. They're the brains of the aircraft. But unlike most smartphones, our electronics have to withstand a wide range of environmental conditions, varying temperature, pressure, and humidity, as well as high-intensity radio interference. Our task is designing these devices to be as lightweight and compact as possible while providing multiple levels of redundancy. Typically, most aircraft makers buy their electronics from suppliers that make devices compatible with a wide array of aircraft designs. For us, that just wasn't possible. When we started building full-scale prototypes 5 years ago and surveyed the market for electronics, we found that off-the-shelf systems included functionality we didn't need or were lacking functions we did. Using third-party systems required really significant trade-offs on volume, weight, and complexity that we weren't willing to make, because every kilogram we're able to save translates to more time savings and lower costs for our customers. And since we own the entire tech stack, we'll be able to verify and deploy software updates over the life of the fleet following FAA approval. The flight electronics are just one piece of the hard engineering challenges we've tackled at Joby. By taking an in-house approach to design, we've been able to build a lightweight, high-performance electric aircraft that will bring the world closer together and change the way we experience flight.